So in section 3, we're going to start talking about the unit circle. And the unit circle is when we can draw a circle on the coordinate plane that has a radius of 1 and is centered at the origin. So in this picture, we've drawn our coordinate plane. We've labeled, if we have a radius of 1 on each axis, we get the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So every point, so we've drawn a point x, y on our unit circle, all of those points are exactly 1 unit from the origin, since the distance from the origin to any point on the circle is just the radius. And the way we get those coordinates x and y is by constructing a right triangle from that point. So if I draw a line straight down to the x-axis from that point, we get a right triangle constructed. And instead of using the angle theta that starts on the positive x-axis and lands on our terminal side, we typically use the angle formed starting from our angle that goes to the closest x-axis. So we typically, when we're talking about these right triangles, to get those points on the unit circle, we use the theta formed starting from the terminal side to the x-axis, the closer x-axis, whether that's the negative or the positive x-axis, depending on where your terminal side of your angle lies. So knowing that the radius r is 1, we can rewrite all of our trig ratios using the plane. So if we start with sine, if we go back to this picture, going from our angle theta that's formed with the x-axis, sine, and we label the x and y coordinates, so this is x along the bottom here, and then this is y, and our radius is 1. The opposite side would be y, and our hypotenuse would be 1, which is just going to simplify to y. So sine of theta becomes just y, cosine of theta becomes x, tangent of theta becomes y over x, which is just the division of sine and cosine. Cosecant, which is the reciprocal of sine, is 1 over y, or 1 over sine. Secant is going to be 1 over x, or 1 over cosine, and cotangent is going to be x over y. And these 6 ratios are going to be very important when we're dealing with the unit circle. We're going to come back to the ratios involving x and y a lot, not so much the ones that involve sine and cosine, but because we're talking about points and x and y values, we're going to use the ratios that involve x and y. So we start with some examples. So we know the point on the unit circle on the terminal side of theta, and we know sine and cosine just by the coordinate, since sine is y and cosine is x. It's a very important piece of information. Cosine of theta is always the x value of our point, and sine of theta is always the y coordinate of our point. So based on this information alone, we can find all 6 trig ratios for a given point on our unit circle. So starting with the point square root 2 over 2, square root 2 over 2 on the terminal ray of theta, we want to find our 6 trig ratios. So just from this information, we already know sine and cosine. So we know sine of theta is going to be the y coordinate. We label x and y, which in this case is going to be square root 2 over 2. And cosine of theta is the x value, which is also square root 2 over 2. All of our other trig ratios involve simplifying based on these 2 ratios. So tangent of theta, which you can either express as sine over cosine or y over x, is going to be square root 2 over 2 divided by square root 2 over 2. And because we're dividing the same thing, we're just going to end up with 1. Now we can do our reciprocal function. So the reciprocal of sine is cosecant. So cosecant of theta, the reciprocal of square root 2 over 2 is 2 over square root 2. Or if you rationalize the denominator by multiplying by square root 2 over square root 2, you end up with 2 square root 2 over 2, which is just square root 2. Same thing for secant of theta. Because in this case alone, sine and cosine are the same, secant would also be 2 over square root 2, which when rationalized becomes just square root 2. And then cotangent of theta, which is the reciprocal of tangent, which is just 1, and the reciprocal of 1 is going to be 1. So our second point is the point negative square root 3 over 2, negative 1/2. So again, labeling x and y so we can figure out sine and cosine. Sine of theta is going to be negative 1/2, and cosine of theta is going to be negative square root 3 over 2. Tangent of theta is going to be sine over cosine, so negative 1/2 divided by negative square root 3 over 2. And we want to simplify. So we can think of negative 1/2 divided by the negative square root 3 over 2 as negative 1/2 times negative 2 over square root 3. Because dividing a fraction by another fraction is the same thing as multiplying the fraction in your numerator by the reciprocal of the fraction in the denominator. So in this case, the 2's are going to cancel, and when I multiply straight across, I'm left with a negative 1 times a negative 1, which is going to be 1, over 1 times square root 3, which is just square root 3. Or if you rationalize the denominator, it becomes square root 3 over 3. Now for our reciprocal functions, so cosecant of theta is the reciprocal of negative 1/2, which is going to be negative 2. Secant of theta is going to be the reciprocal of negative square root 3 over 2, which is negative 2 over square root 3, or when rationalized, negative 2 square root 3 over 3. And then lastly, cotangent of theta. Now when we do the reciprocal of tangent, we're going to use the ratio before we rationalize it, so that would be 1 over square root 3, and its reciprocal is just square root 3. So if you're given a point, it's pretty easy to find all 6 trig ratios since 2 of them are already given to you, and then it just becomes simplifying to find the rest. So let's go ahead and take a look at the actual unit circle. So in that last section, in section 2, we filled out that circle where for 30, 45, 60, 90, so all of those points around the unit circle, I converted them all to their radian measure and talked about how those were the values that we were most going to use. So that's where the unit circle comes from, is all of those points on those angle measures on the unit circle. And in here, we've just gone ahead and added all of these coordinates. Now, these coordinates come from our special right triangles. So if we look at this first triangle here for the 30-degree angle, and I drop my point down to form my right angle, theta is 30 degrees. And we get the square root 3 over 2 1/2 from the relationship in a 30, 60, 90 special right triangle. So we know that the angle opposite of 30, which is going to be our y, this is our x, we know it is half of our hypotenuse, which is where we get the 1/2. And the other side is square root 3 times that unit side, if you will, the side that's y, and that's where we get the square root 3 over 2. So all of these points come from those special relationships we have in 30, 60, 90 right triangles and 45, 45, 90 right triangles. So all of these points come from those special right triangles. So that's where we get the coordinates. And then depending on what quadrant we're in, it gives us the sign. So everything in the first quadrant is positive. So sine, cosine, tangent, secant, cosecant, cotangent, they're all going to be positive in this first quadrant. In the second quadrant, remember, so this is positive x, positive y. In quadrant 2, x is now negative and y is positive. So any trig ratio involving x is going to be negative, which is cosine, tangent, secant, and cotangent. And any trig ratio involving just y is going to be positive, which is just sine and cosecant. We move to quadrant 3, and both x and y are negative. So we get negative x, negative y. which means anything involving just x or just y in its trig ratio is going to be negative, which is sine, cosine, secant, and cosecant. And our positive ones, which is what involves x and y, which is tangent and cotangent. And then our last quadrant, which is x negative y, anything involving sine, in this case, or y, is going to be negative. So sine, tangent, cosecant, and cotangent, and anything involving just x is going to be positive, which is cosine and secant. Do not lose this paper of your notes. It is going to become very important for when we talk about trig. You're going to use it, reference it a lot in the coming modules and sections, and this is kind of like the basis of what we're going to continue doing. So I do not lose this paper. It's going to come in very handy. You're going to reference this a lot in assignments and quizzes, tests, everything for the next few modules, as I said. So let's go ahead and use the unit circle to find trig ratios. So if I give you an angle that's on the unit circle, we can identify its point and then find our 3 trig ratios. So we want to know the 6 trig ratios for theta equals 7 pi over 4. And if you find 7 pi over 4 on the unit circle, it has the coordinate square root 2 over 2, negative square root 2 over 2. And then it just becomes exactly what we were just doing on those previous examples. So first, we label x and y so we can find sine and cosine. So sine of theta is going to be negative square root 2 over 2. Cosine of theta is going to be square root 2 over 2. Now we go ahead and go to tangent, which is sine divided by cosine, so negative square root 2 over 2 divided by square root 2 over 2. Now we are dividing something by itself, but because we have a negative, when I simplify, the answer is just going to become negative 1. So now all that's left is our reciprocals. So cosecant of theta, the reciprocal of negative square root 2 over 2 is negative square root 2. Secant of theta, the reciprocal of square root 2 over 2 is just square root 2. And I'm getting this all from that previous example we did with just the square root of 2 over 2 and square root 2 over 2 as our coordinates. And then lastly, cotangent of theta, and the reciprocal of negative 1 is still negative 1. So look at our next example. Theta equals negative 2 pi over 3. So remember, negative directions, you go clockwise around the unit circle. So it's not going to be the same point as 2 pi over 3. So if we actually go negative 2 pi over 3, we actually get it's equivalent to the positive value of 4 pi over 3 on our unit circle. So we're basically looking at when theta is positive 4 pi over 3. It has the same point as negative 2 pi over 3, which is going to be at negative 1/2 negative square root 3 over 2. So identify x and y and start with sine and cosine. So sine of theta is going to be negative square root 3 over 2. Cosine of theta is going to be negative 1/2. Tangent of theta, which is sine over cosine, is negative square root 3 over 2 divided by negative 1/2, which if we rewrite as multiplication is negative square root 3 over 2 times negative 2 over 1, which the 2's cancel, so negative square root 3 times a negative 1 is just going to be positive square root 3, and it's going to be over 1, which we don't typically write, so we just get square root 3. Now for our reciprocal functions, start with cosecant of theta. The reciprocal of negative square root 3 over 2 is negative 2 over square root 3. Secant of theta, which is the reciprocal of cosine, is going to be negative 2. And tangent of theta, the reciprocal of square root 3 over 1 is 1 over square root 3. And I'm not going to rationalize the denominators for cosecant and tangent since I already did so on that previous example and we know what they're going to look like. The last example on this page is theta equals 19 pi over 6. Now 19 pi over 6 is not a point on the unit circle because 19 pi over 6 is greater than 2 pi. Remember, one rotation around the unit circle is 2 pi, and 19 pi over 6 is greater than that. So we need to figure out where it's going to lie, its terminal side is going to lie on the unit circle. So if we think of how many times 2 pi goes into 19 pi over 6. So if we, over on the side here, 2 pi, if I rewrite it as a fraction with a denominator of 6, we get 12 pi over 6. So if I subtract 12 pi over 6 from 19 pi over 6 to figure out where we're at, 19 pi over 6 minus 12 pi over 6. Remember, when we have common denominators, we only subtract the numerator, and 19 pi minus 12 pi is going to be 7 pi over 6. So 7 pi over 6 is the equivalent angle to 19 pi over 6 on the unit circle. So that's the theta we're going to use to identify our 6 trig ratio. So if we find 7 pi over 6 on the unit circle, we get the point negative square root 3 over 2, negative 1/2. And then it becomes just like our previous two. Identify x and y, and then we start writing our trig ratios. So sine of theta is going to be negative 1/2. Cosine of theta is negative square root 3 over 2. Tangent of theta is negative 1/2 over negative square root 3 over 2, which if we rewrite as multiplication is negative 1/2 times negative 2 over square root 3, which becomes becomes positive 1 over square root 3. So for our reciprocal functions, cosecant of theta is negative 2, secant of theta is negative 2 over square root 3, and cotangent of theta is square root 3. So as we see, the unit circle is very nice to help us to identify 6 trig ratios because we're already given the two that we need the most. If you know sine and cosine, you can figure out all of the other trig ratios. So the last thing we're going to do is solve the trig equations on our interval 0 to 2 pi by using the unit circle. So we can also go in reverse. If we're given a ratio, we can figure out what the angle on the unit circle is going to be. And we're typically going to be using radian measures here for theta. We can use their degree measure, but we're going to start getting used to using radian measure only because in the future that's going to be the one that we're going to use the most. I'll go ahead and give you both here, but just know that radian measure is the one we're going to use. So when we talk about on the interval of 0 to 2 pi, what we mean is we're just talking about one rotation around the unit circle. We're not going to account for, just on our last example, any angles that are equivalent but involve more than one rotation. So we're just talking about one rotation around the unit circle. So our first one is sine of theta equals square root 2 over 2. So we want to figure out what thetas give us that value. So let's start with the fact that sine is positive. And we want to figure out in what quadrants is sine positive. So remember, sine is our y-coordinate. And if we go back to that page with the unit circle on it, sine is positive in quadrants 1 and 2. So we're looking for when sine is equal to square root 2 over 2 in quadrants 1 and quadrants 2. So that happens when theta is pi over 4 in quadrant 1, which is 45 degrees. And then in quadrant 2, that is when theta is 3 pi over 4, which is equivalent to 135 degrees. So those are our two solutions in one rotation around the unit circle. You can either have theta being pi over 4 or 3 pi over 4. Both give you sine as being square root 2 over 2. So next we look at when cosine of theta equals 1. So remember, cosine is the x value, and the only time we get an x value of 1 is when we're actually at one of our axes, so on the x-axis or on the y-axis. So in this case, 1, 0 happens at 0, which is 0 degrees, and 2 pi, which is 360 degrees. Since this is the starting point for our unit circle, the first point is 1, 0, and that's when the x-coordinate is 1. So our last example is probably the hardest one on here because it involves tangent. Anything that's just sine or cosine is pretty easy since it's a point on the unit circle. But all of our other ones come from taking a reciprocal, or in the case of tangent, actually doing sine divided by cosine. So when we're looking at tangent, just like our first example, we want to figure out when it's positive. Well, no, sorry. In this case, when it's negative. And tangent is negative in quadrants 2 and 4. So we need to figure out which angle measures in 2 and 4, when I divide sine and cosine, give us negative square root 3. So this is where those previous examples come into play, because we've already done examples where we divide sine and cosine and get square root 3 as our answer. And that happened when sine of theta was equal to square root 3 over 2, and cosine of theta was equal to 1/2. And because we're in quadrants 2 and 4, one of those is going to be negative. And it doesn't matter which one, as long as only one of them. So we're looking for the values of theta, for the points that we get. Basically, we're looking for the point 1/2 square root 3 over 2, where one of those is negative. And in quadrant 2, that's going to be at 2 pi over 3, which is 120 degrees. And in quadrant 4, that's the angle 5 pi over 3, which is 300 degrees. So tangent's probably the hardest one to solve for because you have to think about the division when you simplify.